Hello, welcome to Maths with Lloydie. Today we're looking at the paper 2C for the 2023 exam series, 2023. Let's make sure the pen's working. Here's the channel. We have almost got to 1.3 thousand subscribers, which is amazing. And Grays Hockey are, as ever, our sponsors. Now, I'm just going to scroll past question 1 and 2, because if you follow the channel, you'll know that question 1, question 2 appears across all of the preliminary material. So I kind of get those done first, and then I go into the individualized papers. So question 3 is where we're going to start. That was look at that, 16 marks for that question 2. Crazy. So here we are, question 3. Playground slides are designed so that children slow down safely at the end of the slide on a horizontal run out. The diagram shows the dimensions important in the slide design. H is the height of the slide, L is the slope length of the slide, R is the run out. A slide is designed with slope length L equals 3 meters. On this slide, a child has an average speed of 2.04 meters per second down the slope. Work out the time it takes the child to travel down the slope. So speed, distance, time. We need to work out time, so it's distance divided by speed. Our distance is 3 and our speed is 2.04, and we just pop that into the calculator, and to 2 decimal places we get 1.47. Okay, part B. The graph below shows the speed of the child in meters per second, and that's over time as they travel down the slope and along the run out. So it will be here where they hit the run out, because their speed will decelerate from that point. Use the graph and use your answer to question 3A to estimate the amount of time that the child is traveling at more than 2 meters per second. I found this question really challenging. However, from here, you use a ruler, and I will also use my ruler. Get it to 90 degrees there, bring it into here. Just move it a bit more, come on, get there. Like that. Page moved, don't you dare. This is the problem with using the technology. All right, so there we are. There's my dotted line, and you can see roughly there is where the time will be from earlier. So the time we had was 1.47. And then from working this out, we've got 1.4 to 1.6 there. 1.2, 1, 0.8, 0.6, 0.4, 0.2. So that was probably the hardest bit about this question, having to work out the scale of that x-axis. And that's what they're talking about when they say using your answer from 3A, because that peak is at 1.47. It's very close to the middle of here, which would be where the 1.5 is. How have I worked that out? Well, I've got 5, 10, 15, 20, 25, 30, 35, 36, roughly 37 squares, which roughly represented 1.47. And then that roughly equaled, let me just run that through the calculator. Divided by 37, yeah, that roughly equaled 0.04, which if I then times that by 5, because 0.04 is one small square, times that by 5, that gave me 0.2, which meant every block of 5 was 0.2. So that was quite a challenging part of the question. Okay, the next bit is to work out, estimate the amount of time that the child is traveling more than 2 seconds. So I'm going to turn to a darker pen now, rotate this ruler. Come on. There we go. And then we're going to draw a line across where speed is equal to 2. And from that, we're going to need to draw a line where these two cross over. Now, drawing the lines on the graph is really important as well. That is showing our examiner are working throughout this process. So I'm happy with that one. 64, 68, 72, so 0.72. And then here we've got 1.8, 1.84, 1.88, 1.92. I reckon that's 1.94. And then finally, 1.94 subtract 0.72. Gives me 1.22. And your mark scheme will have a range for you to land in, because each graph will be slightly different. Mainly because when they print them, there might be some slight differences in the sizes. But yeah, there we go. Happy with that. Okay. Describe the acceleration of the child on the slope and on the run out. So on the slope, the speed is getting faster and it's a straight line. So we have constant acceleration. And then on the downslide, you can see that that is a straight line and going down. So we have constant deceleration. Do not check my spelling. As long as the words look like that, we're fine. Okay, here we go, another graph. This is quite a big question, actually. I might fill my 15-minute allotment on stream. It's actually, this is a rubbish question. This is the last bit. Look at all this for 1 mark. So when designing playground slides, certain safety conditions must be met. The length of the slope determines the maximum height permitted. This condition is represented by the shaded region, R, on the graph. Which one of the following designs will not meet the safety conditions? So we've got a length of 3 and a height of 1.7, which goes there, that's fine. A length of 2.2 and a height of 1.6. Just inside, so that's fine. A length of 2 and a height of 1.5 is on the line, that's okay. And then a length of 1.7 and a height of 1.4 is ever so slightly outside of that tolerance. In fact, I've actually plotted it at 1.8. It's just slightly to the left. And therefore, it's that one. That is the correct answer. Is that it? Yep, that's it. Question 3 done. I'll see you at question 4.